Hi folks, this is Tim Hawkins here from Microfabricator. Today I'm going to show you some inductive sensors. In particular, inductive sensors working on non-metal beds, which is kind of a contradiction of terms, but we'll see how we actually do that. Many people that use printer bots probably have wooden beds, and they're probably thinking to themselves, you can't use an inductive sensor, but you can. And there's a simple way of actually doing it. So the arrangement I've got here at the moment is I've got a Photech PS-05N inductive sensor. These are really small, lightweight plastic. They're mounted by two small holes at the top. But I've got this hooked into a 12-volt supply, which is what you would normally get on most 3D printers. And the output, I've got a 2.2K resistor across it to make a voltage division, so the 12-volt is pulled down to 4 volts, which is something that we could put into the average electronics board. So if we look at the meter at the back here, it's actually looking at the output of the actual sensor itself, and as you can see, it's actually at 3.95 or 96 volts. So that's well within the range of what you can put into the average ramps or printer board card. Underneath the bed itself, I've actually got a printed circuit board, blank printed circuit board that you can get from Radio Shack. Right, okay, I've got the copper side up here, and on top of that I've got my normal piece of print bed glass, which I normally print onto, including a layer of Capon tape, and it works out at around about 1.5 millimeters thick, so that's quite reasonably thick. And as I bring the sensor down, you can see that the voltage on the voltmeter flips between a very low voltage and 4 volts, right? And it happens around about 2.5 millimeters above the bed. I don't know if you can see that, but it's actually flipping across around about 2 to 3 millimeters above the bed itself. So that means it would be suitable for an automatic Z sensor. So what I'm planning to do with this device is I'm going to basically create a small bracket which actually has long slots on it, the width of the two holes, or separated by the two holes at the top there, so I can adjust the vertical position of the sensor and then lock it into a particular position. And then the whole construct will effectively be bolted into the actual head of the printer itself, using the two bolt holes that are normally used to affix the actual hot end to the head itself. They're a convenient anchor point for anchoring stuff next to the hot end. Because this thing is so light and it's made of plastic, I mean, it can't weigh more than a few grams. It's not going to add any considerable mass to the head itself, so it's not going to negatively affect the performance of printing at all. As you can see, it's actually very, very small, very compact, and nicely sealed. One slight downside with putting the resistor across the output is that it seems to convert the output indicator LED to a permanently on state. I think that's because it's actually pulled down internally now, and the LED, I think, is across the actual pull-up resistor itself, so there's now a small amount of current flowing through it, but that just means that its function converts from being an output indicator to a on-off indicator for the actual sensor itself. It tells you whether you've actually got 12 volts going into it. Normally these devices require around about 6 volts to operate, which means if you're trying to drive them from the 5-volt supply of the Z-stop output that you normally get on either the printer board or the ramps card, you're really operating just below their operating margin, and you could actually have some erratic behavior from them. So driving them from 12 volts with the resistor across the output actually means that they're well within their operating voltage. So there shouldn't be any issues with that at all. Let's just for a moment contrast that with the Amico one, which is the one that PrinterBot, well, it's very similar to the one that PrinterBot is actually selling. This is a much bigger device. It's much heavier. It probably weighs a good 5 to 10 times the weight of the Photech device. It's a lot of mass to actually have on your system. I've wired this one up in the same configuration, and it seems to work exactly the same. So there's no functional difference between them, but it's just really quite a massive device. And you know, devising a mounting clip for that, plus the actual weight of it itself, really puts me off this device essentially. I'll probably use this for another project, but for the moment I'm going to stick with the Photechs. The device number again is the Photech PS-05N, and it seems to work really well. Over the course of the next couple of days I'm going to get this wired into my auto leveling setup. I currently have a servo hooked into the side of my system with a micro switch, so that my system is all set up to do auto leveling, but it's using the old mechanical method, and I really want to move to a much more solid state system which can be done much faster, which means that I can actually level automatically at the front of every print, and that means I can get some really good quality effectively. So anyway, that's it. That's inductive sensors for people without metal heat beds, or without metal print beds, sorry.